What if your body simply forgot how to fall asleep? Not for a night, not from stress or caffeine or a bad mattress, permanently. Every single human being on Earth, all 8 billion of us, fully awake, indefinitely. That question sounds like science fiction, but the science underneath it is completely real. And when you follow the biology from the first sleepless hour all the way to the absolute edge of human survival, what you find is not what most people expect. This is not a story about feeling tired. This is a story about what your brain is actually doing when it forces you to close your eyes, why it cannot stop doing it, and what happens to a mind and a civilization when that system begins to break. Let's start at the beginning. Right now, before a single hour of sleep loss has passed, something is already happening inside every brain on the planet. Every moment a neuron fires, it produces a chemical byproduct called adenosine. Think of it like exhaust from an engine. It builds throughout the day, accumulating in the brain's tissue, pressing against the walls of your alertness like pressure inside a sealed container. The longer you stay awake, the more adenosine builds, the heavier that pressure becomes. Sleep is the release valve. It flushes the adenosine out, resets the pressure, and lets the brain start again. That image matters. Remember it, we will come back to it. After 16 hours of continuous wakefulness, something measurable happens. Cognitive tests show that a person who has simply been awake since a normal morning, someone who has not done anything unusual at all, is now functionally impaired to the same degree as someone with a blood alcohol level of 0.05%. That is just below the legal driving limit in most countries. And most people at that stage feel completely fine. They do not feel drunk, they feel awake. That is the first deception sleep deprivation plays. The damage is real, the awareness of the damage is not. Push to 24 hours and the numbers get serious. Reaction times slow by up to 300%, decision-making fractures, emotional regulation, the mental process that keeps a person from overreacting to minor stressors, begins to collapse entirely. The brain starts rerouting signals, misclassifying neutral events as threats, flooding the body with a stress response it does not need. Cortisol spikes, blood pressure rises, the immune system begins to suppress itself, pulling resources away from defense and toward emergency energy production. At 24 hours, the body is not resting, it is quietly panicking. And across a planet where no one sleeps, that panic is happening simultaneously in every office, every hospital, every cockpit, every control room on Earth. Not dramatically, not visibly, just steadily, invisibly, in 8 billion brains at once. But here is what is really happening underneath all of that, and this is the part most people never think about. The brain has a waste clearance system called the glymphatic network. It works almost exclusively during sleep. While the body rests, the brain's cells actually shrink slightly, opening channels between them, and cerebrospinal fluid flows through those channels like a pressure wash, flushing out the toxic metabolic byproducts that built up during the day. One of those byproducts is beta amyloid, a protein that accumulates in the brain and is strongly associated with Alzheimer's disease. Without sleep, the glymphatic system shuts down almost entirely. The waste stays, it accumulates. And with each passing hour, the question is not just what the brain is losing, it is what the brain is filling up with. What is the brain actually doing during sleep that it simply cannot do while awake? That question has an answer. But the full answer is stranger than you would expect. We will come back to it. For now, hold that thought, because we are about to cross into the territory where things stop being merely dangerous and start being something else entirely. At approximately 72 hours of continuous wakefulness, 3 full days without sleep, the human brain begins to hallucinate. Most people, when they hear that, picture random visual noise, smeared light, blurry shapes, a brain too exhausted to process input correctly, flickering like a dying television. That is not what happens, not even close. What actually happens is this: a brain denied sleep long enough does not simply malfunction. It begins forcing fragments of REM sleep into waking consciousness. REM is the sleep stage associated with dreaming. It is the state where the brain is most active, consolidating memory, processing emotion, running internal simulations. When sleep is denied long enough, the brain does not wait for permission. It begins inserting dream sequences into waking life, a phenomenon researchers call REM intrusion. The hallucinations are not random, they are structured, they feel real, they follow narrative logic, and the person experiencing them often cannot tell the difference between the hallucination and the physical world around them. The brain is not broken. It is trying to dream with its eyes open. And here is the part that should make you stop for a second. This is not happening to someone in a lab under unusual conditions. At 72 hours, this is the predictable, documented, biological response of any healthy human brain pushed past its limit. Every person on a planet that cannot sleep would arrive here, all 8 billion, simultaneously dreaming while awake, with no way to tell the dream from reality. If you have wondered what the upper limit of human survival without sleep actually is, you are not alone. Scientists have debated it for decades. Drop a comment below with what you think the real limit is, because the answer, when we get there, is one of the most unsettling things in sleep science. At this point in the timeline, roughly the 72 to 96-hour range, EEG scans of sleep-deprived brains begin showing activity patterns that are almost indistinguishable from those seen in acute psychosis. The dopamine dysregulation visible in the scans mirrors what researchers observe in patients with schizophrenia. It is not a metaphor, it is a biological measurement. Think about what that actually means. 4 days of no sleep does not just impair judgment. It temporarily produces a brain state that is clinically equivalent to one of the most severe psychiatric conditions known to medicine. And in a world where no one sleeps, this is not a hospital case. It is the baseline state of the entire population, spreading outward like a wave, day after day, person after person. Now, we know these things in part because of one extraordinary experiment, and the person at the center of it was 17 years old. In December 1964, a high school student named Randy Gardner in San Diego, California, decided to break the world record for voluntary sleep deprivation, not in a laboratory, not with an institution behind him, in his bedroom with 2 friends watching, and eventually with Stanford sleep researcher Dr. William Dement supervising directly to ensure his safety. Gardner's goal was 264 hours, 11 days. By day 4, he began experiencing paranoid episodes. He mistook a street sign for a person. He was not confused about it. He saw a person standing in the dark, turned to look directly at it, and it was a sign. His brain had inserted a figure into reality so convincingly that his eyes reported it as true. By day 9, his short-term memory had degraded so severely that he could not complete sentences. He would begin a thought, lose the thread entirely, and have no recollection that the sentence had even started. By day 11, he could not add single-digit numbers. Read that again. After 11 days without sleep, a perfectly healthy, intelligent 17-year-old could not reliably calculate 2 plus 3. Keep that image in mind, because something is about to happen that will make it mean something very different. Gardner crossed the 264-hour mark. He had been awake for 11 days and 24 minutes, and then he slept. He slept for 14 hours and 40 minutes, and when he woke up, his cognitive function had returned to near baseline within days. He went back to school. He recovered. Here is the reassuring version of that story. The human brain is remarkable. The glymphatic system catches up. The adenosine pressure is released. Sleep debt, at least from a single extended deprivation event, can be repaid. The brain is resilient. Gardner is proof. That is actually the conclusion most people land on when they hear this story. The body has limits, but it recovers. Push hard enough and long enough, and the machine resets. If you are finding this compelling, subscribe. There is a deeper layer to this story coming, and it changes everything that came before. But now comes the part of this that no one talks about, the part hiding beneath the Gardner story, because there is a question that Gardner's recovery, paradoxically, makes more disturbing, not less. What if the system that allows recovery is itself destroyed? There is a disease called fatal familial insomnia, FFI. It is a prion disease, meaning it is caused by a single misfolded protein. That protein, once misfolded, triggers a chain reaction that destroys a specific region of the brain called the thalamus, which is the structure responsible for regulating the transition into sleep. When the thalamus is sufficiently damaged, the person loses the ability to sleep, not the desire to sleep, the ability. Fewer than 40 families in the entire world carry the gene mutation that causes FFI, fewer than 200 documented cases in all of recorded medical history. The disease is extraordinarily rare. But what it does is not rare in concept. It is exactly what we have been describing, only it never stops. FFI patients in the early stages notice increasing difficulty falling asleep. They feel tired. The adenosine pressure builds. The sealed container tightens. But the release valve, the mechanism that allows sleep to begin, is being physically dismantled, neuron by neuron, inside the thalamus. As the disease progresses, they stop sleeping entirely. And then the same sequence that Randy Gardner moved through in 11 days begins to unfold in a person who has no endpoint, no morning when the experiment ends, no 14-hour recovery sleep waiting on the other side. FFI patients do not simply feel exhausted. Their brains begin generating waking dreams they cannot exit. They experience exactly what Gardner reported at day 4 and day 9, hallucinations indistinguishable from reality, paranoid episodes, the complete fracturing of short-term memory. But it is not day 4. It is week 12, month 4. The hallucinations do not fade, they deepen. The body follows. Patients experience severe temperature dysregulation, their core temperature swinging unpredictably as the body loses its ability to regulate basic functions. Blood pressure becomes erratic, the immune system deteriorates. Weight drops rapidly as the body burns through itself trying to maintain any kind of stability. Average survival after full insomnia onset in FFI patients, 6 to 36 months. There is no treatment, there is no cure. The thalamus, once destroyed, does not regenerate. This is not a hypothetical. This is a documented disease that has already happened to real people, and every single one of them, at some point during their illness, passed through the exact same neurological territory that Randy Gardner voluntarily entered and then left. They simply had no way to leave. Now return to the adenosine image. The pressure building inside a sealed container, every waking hour, every firing neuron, every moment of consciousness adding weight to a system designed to eventually open and release. In a healthy brain, that pressure builds, sleep comes, the valve opens, and the pressure falls. Every night, for decades. Gardner's experiment showed us what the pressure looks like when it is held too long. Terrifying but temporary. In FFI patients, the valve is physically gone. The pressure builds. It never releases. The brain, denied the mechanism that would allow true sleep, begins forcing dream fragments into waking life, not because it is broken, but because it is desperately, biologically trying to do the one thing it needs to survive. It is trying to sleep while fully awake. It is trying to find the release valve that is no longer there. And the harder it tries, the more the hallucinations deepen, the more the waking dreams spread, until the line between what is real and what the brain has manufactured no longer exists at all. That sequence, that specific collapse, is caused in FFI by a single protein. One protein, folded the wrong way, in fewer than 40 families across all of recorded history. Stay with that number for a moment, because what follows from it is the part of this story that is almost impossible to sit with comfortably. There is a Vietnamese man named Thai Ngoc who reportedly went without sleep for 33 years following a fever in 1973. The case was never rigorously verified under clinical conditions and remains scientifically contested, but the fact that it exists as a story, that it circulates, says something about how desperately people want to believe the limit does not exist. That sleep is optional, that with enough will or enough illness the body finds another way. The animal data suggests otherwise. Rats kept completely sleep-deprived in laboratory conditions die within 2 to 3 weeks, not from a single identifiable cause but from systemic collapse, organ failure, immune breakdown, severe temperature dysregulation. The body does not adapt to no sleep, it dismantles itself. There is a reason scientists do not like to talk about the theoretical upper limit for humans under conditions like FFI. The numbers are not clean, the mechanisms are not fully mapped. But everything we know about adenosine accumulation, glymphatic failure, thalamic function, and the progressive collapse of dopamine regulation points toward a system that was never designed to run without interruption. Sleep is not something the body does when it has nothing better to do. It is not recovery. It is not rest in the way we usually mean that word. It is an active biological process, a critical maintenance window the brain opens every single day, because without it, the machine begins to eat itself. The glymphatic channels close, the beta amyloid builds, the adenosine pressure climbs, the REM fragments break through into consciousness. And eventually, if the window never opens again, the brain spends its final months doing something that should be impossible, dreaming with its eyes open, unable to stop, unable to wake up from dreams it is already awake for. Randy Gardner went 11 days and came back. He walked out of the experiment and came back. That recovery feels reassuring, but it was only possible because the system that was temporarily overwhelmed was still, underneath all that exhaustion, structurally intact. The pressure had somewhere to go. In FFI, it does not. And that one difference, a single protein folded wrong, in fewer than 40 families across all of human history, turns the most ordinary thing a body does into something irreversible, something that runs in one direction only. The brain keeps trying to do what it has done every single night of a person's life. It keeps reaching for sleep. It keeps generating the signals, the fragments, the dream logic. But the door is sealed, and the knock never stops. If this video made you think about something you normally take for granted, hit like. It genuinely helps this channel reach more people, and subscribe if you want to keep going. 2 videos are on screen right now. Click whichever one pulls you in.